Hello, everyone. Welcome again to the Math Magician's Den. This is the Herm Dog. We are going to talk today about some basic rules for derivatives. First of all, what is the constant multiple rule? What's a constant multiple rule? Well, the constant y equals 4. I think all of you can agree 1, 2, 3, 4. That is a horizontal line. And remember, derivatives are the slope of a horizontal line. So what is the derivative of 4? The derivative of y is y prime. The derivative of 4 would be the slope of that line. It would be y prime equals 0. Same thing on the next one. What's the derivative of a constant? Well, the derivative of f of x is f prime of x. The derivative of negative 5 would be 0. What's the derivative with respect to x of pi? Well, pi is a constant. The derivative of a constant is 0. Right here's the rule. The derivative of a constant is 0 because a constant represents a horizontal line, and the slope of a horizontal line is 0. Now, our power rule. How do we do the power rule for derivatives? The power rule for derivatives says this: you bring the number out front and multiply, and then you subtract 1 from the exponent. Okay? We've got to be careful with this when x equals 0, but other than that, the power rule works very, very well. This first problem at the bottom of the page, the derivative of f is f prime of x. Now watch how the power rule works. You bring the 5 out front, and you just subtract 1 from the exponent. There's your power rule. The derivative of f of x here would be 5x to the fourth. Now what happens if you run into a problem where you have a fractional exponent, like the cube root of x? That's actually x to the 1/3. So we're going to rewrite it as x to a power. Now, what would be the derivative of this function? Well, f prime of x, you would bring the 1/3 out front, then you would subtract 1 from the exponent, and 1/3 minus 1 is negative 2/3. Now we know that rule, you can't have a negative exponent, so this would be 1 over 3, and that x would be thrown on the bottom, and it becomes positive 2/3 for its exponent. Here is the derivative for that function. This derivative rule works with negative exponents. This would be x to the negative 6. Write it as x to a power first. Then when you take the derivative, f prime of x, you would bring the exponent out front and multiply, and you'd have to subtract 1 from the exponent. That would make this negative 7. So the derivative is going to be the negative 6 will stay on the top. Negative exponent, you put it in the opposite part of the fraction and change the sign on the exponent. So the derivative here would be negative 6 over x to the 7th. Power rules, when it comes to doing derivatives, you've really got to get good at power rules, because eventually we start building on this. For example, how do you find the slope of a tangent line of a function at a given point? Well, what we're going to do first is we're going to take the derivative of each one of these functions. So for example, right here, y prime, what would it equal? Y prime would be, bring the 4 out front, x would now be raised to, subtract 1 from the exponent, x cubed. Now what I've just written here is I've written the derivative. This is the slope of this function at any point on this function. So how do I find the derivative at 2? How do I find the slope of the curve at a specific point, like 216? Well, here I'm going to plug in 2 for x. And if I work this out, I'm going to get 32. The slope of this function at the point 216 is 32. Now, I'm going to go right to the problem below it, because the problem below it says, hey, let's write the equation of the tangent line. And the formula that I'm going to use, and this will be easy because essentially I have a slope, which I found to be 32, and I have a point 216. So, sorry guys, I'm not going to use slope-intercept form. I'm going to use point slope. Y minus y sub 1 equals my slope times x minus x sub 1. This is the point slope formula. And how does it work? Well, I already know my slope. My slope I found from the derivative, it's 32. My coordinate, this would be x sub 1. This would be y sub 1. So it would be y minus 16 over here, and in the parentheses over here, I'd put x minus 2. That is the equation of my tangent line. Now, I could put this in slope-intercept form. I could distribute the 32, make it 32x minus 64. Then I could add the 16, and I'd get y equals 32x minus 48, which is fine. That's the correct answer too. But why not just use point slope? So we're going to do the same kind of thing on this next problem. Remember, this is x to the 1/4. So how would I find the derivative of this function, x to the 1/4? Well, f prime of x would be, I'd bring the 1/4 out front, and now it would be x to the, subtract 1 from the exponent, you get negative 3/4. So this would be 1 over 4 x to the 3/4 power. That is my derivative. Well, I want the derivative here at 81. So this would be 1 over 4, 81 to the 3/4 power. Now remember, with AP exams, you may have to do this without a calculator. So when you're doing a fractional exponent, do the root first. The 4th root of 81 is 3. 3 cubed, 27. 4 times 27 is 108. The slope of the tangent line is 108. So how would I write the equation of my tangent line down here? Well, again, it would be y minus the y value, which is 3, equals my slope, which is 1 over 108, times x minus the x value, which would be 81. There is my tangent line for that particular function at that particular point. One more here. What if I wanted to do this function? Everyone agree that this would be x to the negative 4. Well, my derivative, bring the negative 4 out front, subtract 1 from the exponent. My new derivative would be negative 4 over x to the 5th for this particular function. But what is my derivative at negative 1? Well, this would be negative 4 over negative 1 to the 5th, and if we did our math, this comes out to be positive 4. That is the slope of my tangent line to this function at the point negative 1, 1. And again, how do I write the tangent line? I have a point, I have a slope. Y minus the y value equals the slope I just found from the derivative times x minus the x value. And when you subtract negative 1, you're going to get a plus 1. Now, if I distribute here, I would get 4x plus 4, but then I'd have to add 1. I would get y equals 4x plus 5. So you can write it in slope-intercept form, or you can write it in point slope form. And if I go to Desmos here and I were to graph this function, and it's basically 1 divided by x to the 4th. There's my graph. And let's put in y equals 4x plus 5. Notice where it hits tangent to that curve. Negative 1, 1. Notice that curve is increasing at that point. That's why it has a positive slope. So this does work, finding tangent lines to the curve. Just use your derivative. Okay. Now, we're also going to talk about this constant multiple rule. What happens if I take a constant times a function? Well, you're going to take the constant times the derivative. So, for example, we've got some problems here. In the homework I give to the kids, it always says, rewrite your function so it's a number times x to a power. In this particular problem, it would be 3 times x to the negative 1. Well, what would the derivative be? First of all, make sure you keep track of your notations. This would be f prime of x on the left. You would bring the negative 1 out front, so I'd have negative 3. And then you would subtract 1 from the exponent. It would become negative 2. And then I tell them to rewrite my derivative and simplify it. This would be negative 3 over x squared. There is my derivative for this function, where it's 3 times the function. The next one, we also have 4 times a function. This one would be f of x equals 4 times x to the 1/2. Well, with your derivative, you're going to bring that 1/2 out front and multiply, just like it says here. You're going to multiply by c, or we're going to multiply by 4. That would give me 2. Subtract 1 from the exponent. And then rewrite your derivative so it's simplified. This would be 2 over x to the positive 1/2, which is 2 over radical x. And I tell my students it doesn't matter to me if you write it with a radical or if you write it with a fractional exponent. They're both correct. This one started out with a radical, so I'll make sure I write it with a radical. And we're going to do the same thing on the next problem. We are going to rewrite this function, okay, so that it is a number, which is 7/3, times x to a power. Well, the power's on the bottom, so this would be negative 2/3. How do you find the derivative? You would bring this exponent out front. That would give me negative 14 over 9. And if I subtract 1 from the exponent, I get negative 5/3. So my derivative here is going to be negative 14 on the top, 9 on the bottom, and that x will put to the 5/3 on the bottom, simplifying that negative exponent. Now, I've had kids get caught on this next one because they don't realize when you simplify this, you have to cube the 2 and you have to cube the 8, or cube the 2 to get 8, cube the x to get x cubed. So now when I take the derivative, it gets really easy. You just bring the 3 out front, it would be 24. Subtract 1 from the exponent. We don't even have to rewrite this one. There's your derivative. One more idea before I let you go today. When you add functions, f of x plus g of x, okay, you can add their derivatives. When you subtract functions, you can subtract their derivatives. So when you get a function like this, f of x equals this polynomial, just take the derivative of each term. The derivative of the first term would be 3x, subtract 1 from the exponent. The second term would be bring the 2 out front and multiply, subtract 1 from the exponent. And what's the derivative of a constant? The derivative of the 5 is 0. Now, most of the time, we're probably not going to write the 0. So here's my derivative. F prime of x equals 3x squared minus 8x. And that is the derivative at any point on the curve. Now, before I do the derivative of this next one, I'm going to rewrite it as power, or as a number times x to a power. So this would be 1/4 x squared plus 2x to the first. And I know we usually don't write to the first, but I think it will help here. Plus 5x to the negative 1. Now, that's not the derivative. That's just me rewriting the function so it's a number times x to a power. And finding g prime here will now be easier. Bring the 2 out front. I would get 2 over 4. That would be 1/2. And x would be raised to the first. Bring the exponent out front. That would give me 2. But if you subtract 1 from the exponent, I get x to the 0. And x to the 0 is just 1, so the derivative here is just 2. Next one, bring the exponent out front. I would get negative 5. And if you subtract 1 from the exponent, I'm going to get x to the negative 2. Well, that puts the x squared on the bottom. Here's my derivative. Watch your negative exponents, everybody. One more here. Rewrite this function. This would be x to the 2/3 plus 2x to the 1/2. Makes my life easier if it's a number times x to a power. So what's g prime of x? You'll notice every time if it's f of x, I write f prime. If it's g of x, I write g prime. If it was y, I'd write y prime. First problem, I'm going to put 2/3 x to the negative 1/3. Next problem, if I bring the 1/2 out front, it cancels with the 2, and I subtract 1 from my exponent. So the first term would be 2 over 3x to the 1/3, or the cube root of x. The next term would be 1 over x to the 1/2, or the square root of x. So you notice all I'm doing with my power rules, each term I take the derivative. If I add the terms in the derivative. If I subtract the terms in the derivative. Hope you liked this video. If you did, please hit the like button and subscribe. I'll be posting more videos later.